Hello everyone and welcome back in our third session of shear force and bending moment diagram. In last two classes we have developed some basic understanding that how to make the shear force and bending moment diagram for simple problem, like we are having a cantilever beam with a point load, then this would be the shear force and this will be the bending moment diagram. That is what we have seen in our previous class. In addition to that, we have also seen that if we are having multiple loads, then how the shear force and bending moment diagram will look like. So this is our practice session where we are going to solve this problem, and in the problem you can see there are three loads: 60 Newton, 100 Newton and 150 Newton acting at a distance of 4 meter from the right end. Then after 2 meter I am having a load in the upward direction. Before I solve the problem, let me remind you that we are having a sign convention that if the load is acting in the downward direction, the shear force will be considered as negative, and if the load is acting in the upward direction, the shear force will be positive. Similarly, we have our sign convention that if I am making a bending moment diagram and my bending moment diagram having a counterclockwise sense or the direction, I am going to take it as a positive value, and if it is having a clockwise sense, then I am going to take it as a negative. When I will solve this problem, we will use this convention. So no need to remember this, but please understand that there will be a sign convention, because when you will see different books will have different approach to solve the problem as well as the different sign convention. My convention is what I always start with the extreme right point and then I move toward the left side. So without any delay, let's try to solve the problem. So this is my problem statement, and first I am going to make the shear force diagram for this given problem. Here you can see that there are three loads acting at three different positions, and we have to find first the shear force at point D. As I said that I am going to start at extreme left point and then I will move from extreme right to the extreme left point. So the shear force at D, shear force at C, shear force at B and shear force at A. In addition to these 4 points, I am also interested to find the shear force between the point. For example, I would like to say that what would be the value of shear force when I am moving from D to C. And what is our philosophy to solve the problem? What we do, I am walking from point D to point A, and I am going to collect all the loads coming in my way. So when I am at point D, I am having a load of 60 Newton in my hand, and as per sign convention the load is in the downward direction. So I will say that the shear force at point D will be what? Minus 60 Newton. When I am moving from D to C, there is no any other load is coming in my way. That means from D to C the shear force will remain constant as 60 Newton. That's we will see when we will start our shear force diagram. So let's make the shear force diagram. This line is representing the beam, and above this line I am going to consider the positive shear force. Below this line the shear force will be negative, and I am starting my shear force from point D. So at point D, I know that the shear force is minus 60, so I am going to make a line in the downward direction representing that this is showing a magnitude of 60 Newton in the downward direction. As I said, when I am moving from D to C, there is no other load is coming in my way. That means the shear force will remain constant up to point C. When I will reach at point C, second load that is of 100 Newton is there. So I can assume that when I started from D, the total load in my hand was 60. When I will reach to point C, the load will increase by an amount of 100. So the shear force at point C will become what? Earlier I was having 60 Newton load, and then again 100 Newton load is there and in the downward direction, so the total shear force will be minus 160 Newton. Here I am going to make it in absolute way. That means that 160 is going to be represented with respect to this line. I am already having a 60 Newton in the downward direction, so I have to increase the shear force, and I am saying that this increment is of amount 100. So the total shear force at this point will be the 60 and 100, total 160. Beyond C, again I am moving towards point A, but there is no additional load is coming. That means from C to B the shear force will remain constant. When I will reach to point B, again I am having a load of 50 Newton, but please remember the 50 Newton load is acting in the upward direction. So what would be the total load? Earlier there were 60 Newton and 100 Newton, but now the load is in the upward direction, so I have to write in the positive sense. So this is the 50. So the total final load will be what? Minus 110 Newton. That means the shear force at point B will change from a value of minus 160 to 110. So I am going to move in the upward direction, and this length is actually 50. So what would be the remaining? The remaining will definitely 110, because earlier it was 160. Beyond B again there is no change. So from B to A there will not be any change, and this will be the straight line, and at point A the shear force diagram is going to be closed. Now why it is going to be closed? This is actually related with the reaction at the support. If I will calculate the reaction on the beam because of the support, there will be a upward force of magnitude 110 Newton. The reaction you can calculate, that is a separate part. I am not going to tell you how to calculate the reaction. If you are interested, watch my previous video related to rigid body and you will find how to calculate the reaction. So because of this reacting force, the shear force diagram is going to be closed, and this is finally the shear force diagram, which is in the negative side, because the shear force at every point minus 60, minus 160 and minus 110, and when I will reach to point A, I will say that the shear force will become 0, but it is not actually 0, it is changing from a value of minus 110 to the 0. So if you will write 0, this is again okay, or minus 110, that is also okay. But what actually we are going to see, we are going to finally see what diagram you are going to make. So this is the correct shear force diagram of this problem. After understanding the shear force, let's make the bending moment of the same problem. Let's make a separate diagram and solve the problem for the bending moment. So this is my problem statement, and this time I am interested to find the bending moment. So what I will do, I will find the bending moment at point D, bending moment at point C, bending moment at point B, as well as the bending moment at point A. But in addition to this point, I will also find the bending moment when I am moving from D to C, or from C to B, and from B to A. So let's start with the point D. At point D, I am having a load of 60 Newton. Please understand, this is a procedure and you have to remember the procedure. Once you will understand the procedure, the problem will become very simple. What you need to do, you have to simply calculate the bending moment when you will move from one end of the beam to another end. So here I am at point D first, and load is acting at point D. So the bending moment at point D will become what? 60 into 0. So ultimately it will be 0. Till this point, I don't know what would be the direction of the bending moment, because I am at point D and load is also acting at point D. But beyond that, when I am interested to find the bending moment between the section CD, before I will start finding the bending moment at point C, I am interested to find the bending moment between point C to D. And to get the bending moment between point C to D, what I need to do? I have to consider a distance x between point D to C. And please, as I said, that this is a procedure, conventional method. So you have to remember, whenever we calculate the bending moment between 2 points, we consider x value, and then we write the expression for the x. In this case, my bending moment at point X, which is between C to D, will be what? The load is acting in the downward direction. The point is here, and the distance of the point from the load is x. So the bending moment will be 62 into x. And what is the sense of the bending moment, whether it is clockwise or counterclockwise, that we can visualize. We are having a beam like that, which is having a joint here, suppose, and the load is acting in the downward direction, and this is my x. So what would be the sense of moment at this point? Since the force is acting in the downward direction, and if this is my body, at this point the load is acting towards the right, so body will try to rotate in this direction. So this is how you can find the bending moment. Let's take another example. Suppose this is my body and the load is acting at this point in the upward direction, and I am interested to find the moment at this point. What you need to assume? You have to assume that this body is having a pin joint here, and when I will apply a load in the upward direction, the entire body is going to be rotated in the clockwise sense. So this is a movement of clockwise sense, this is also a movement of the clockwise sense. If the load will change the direction, or you will change the point position of the point from one side to another side, the sense of the movement will change. So here also the load is acting in the downward direction and the point is towards the left side, that means the bending moment sense will be clockwise. So instead of writing the clockwise, what we do, we put a negative sign which indicate that the bending moment is in clockwise direction. This equation is actually valid till point C, because I have assumed x for a region from C to D. So when I will reach at point C, the x value will become what? The x value will become 4 meter. So the bending moment at point C will become what? So I am going to put this x value in this expression. So it will be minus 60 into 4, that is minus 240 Newton meter. Let's make the bending moment diagram. So here also I am going to represent my beam with this line. Above this line it is positive bending moment, below this line it is negative bending moment. I am at point D and I know that the bending moment at point D is what? Bending moment at point D is 0. So I will start from this point, and when I am reaching at point C, the bending moment is minus 240. So ultimately I have to reach somewhere here. But what would be the variation of bending moment while I am moving from D to C? So you can see this expression. This is a linear expression where you can visualize this bending moment is proportional to x. That means the change is linear, and when you are reaching at this point, the value of the bending moment will be what? The value of bending moment will be minus 240. Beyond C, again you are moving from C to B. So what you need to do, you have to assume another x value. But till this point I have considered the x which was valid only up to point C. Now I am interested between C to B. So here the bending moment expression will be right for another x value. So this is now not valid. What I will do again, I will consider another x which is from B to C, and I will write expression for the bending moment at any distance x, but this is for B to C region. And what would be the expression now? My two loads are there, one is 60 Newton load and distance is here, and that is what? That is x. So I will write the expression, that is minus 60 into x. Another load which is of 100 Newton is acting, but the point of action is point C and the point of interest is here, so I am interested in this distance only. And this is what? This distance is actually total distance is x. This is 4 meter. So ultimately the smaller distance will be what? X minus 4. So I am going to write this x minus 4 now, but the load is 100 Newton and again it is in the downward direction, so the moment at this point will be clockwise. So I will put minus 100 into x minus 4. So this is the expression for my bending moment, and this equation is valid till point B, because I have considered my x which is valid up to point B. So in this expression, when I am saying that my x will become what? X will become 6, I will reach to point B. So bending moment at point B will become minus 60 into 6 minus 100 into 6 minus 4. So that 560. So my bending moment will now become, when I am reaching at point B, the bending moment will be minus 560, because the sense is again the clockwise. So I will increase the line, but now the slope will be different. If we will simply increase the line in this fashion, this will not be correct, because this is a linear curve and which is driven by this expression. Now the expression has changed and the magnitude is increasing, that means the slope will increase. So ultimately when I will make the bending moment for point B, I will increase the slope, but you should not be go in proportional. Just write a value of total bending moment at this point will be what? It will be minus 560. Beyond point B, again you need to consider one x expression, but the previous x expression will not be valid now. So what we will do now, we will consider another point here and we will write that this is a value of x. and we will write the expression for this point. So now I am going to consider three loads: the 60 Newton load, the 100 Newton load, and the 50 Newton load. And what would be my expression? My expression will be bending moment for any value x, and that is for between B to A. So there are three loads: 60 into x, 100 into total x minus 4, and this 50 into total x minus 6. When you will carefully see this figure, you will understand that what I am doing. You can see here that there were three loads: 60, 100 and 50. And you are interested to find the bending moment at point between these two values, and you have assumed that this total distance is x, this is let's 4 and this is 2. So for 60 the moment will be what? 60 into x. For 100 the moment will be 100 into x minus 4, and for this 50 it will be just 50 into total distance x minus 6. So with this I can write the expression, but I have to also remember what will be the correct sign based on the clockwise and counterclockwise assumption. So for the point x, it will be minus 60 into x, because the clockwise, minus 100 into x minus 4, and then I am having upward load, so the moment will be counterclockwise, so I will put plus 50 into x minus 6. This is the expression which will be valid up to point A, and when I will reach to point A, at point A, what would be the value of x? When I am reaching at point A, the value of x will be the entire length of the beam. So for the point A, x will become 8. So I am going to put x8 in this expression, and when I will put x8 in this expression, I will get the final value, that will be minus 780. So let's try to draw the 780 on this diagram. But here you should remember, if the load of 50 Newton would have acted in the downward direction, the slope will be increased. But the load is acting in the upward direction. That means if you will continue with this slope, the value will be higher. But as the load is acting in the upward direction, your slope will now reduce. So the finally the line will come in this way and it will end somewhere here. So the slope is changing. Earlier it was this, then the load act in the downward direction, that means the slope will increase. So the slope increased, but now the load is acting in the upward direction, the third load is in the upward direction, so finally the slope will reduce. So this would be the final bending moment diagram for the given case, and the value will at this point will be what? 780. So this is how you have to make the bending moment diagram for the given problem, where you are having three load but one load is acting in the upward direction and entire bending moment diagram is in the negative side.